Okay, let's look at number 5. If you will draw your line down your equal sign, if you're looking for these variables, you'll notice that we have 2 W's. So we know that it's the same variable, so we're just going to solve for W. But they're on opposite sides of the equal sign, so we know that we have to move one of them. It's going to make more sense to move 4/3 W over with 2/3 W. So let's go ahead and move that. And we've got our negative 12 over here. All right, if I'm going to move this 4/3 W, it's positive. So what am I going to have to do to move it?
Subtract.
Subtract. We're going to subtract 4/3 W. Don't forget to put that W with it. You're subtracting that too. Do not lose your variables. So we're going to subtract 4/3 W on this side also. 4/3 W minus 4/3 W goes to 0 and leaves us with negative 12. Equals, what's 2/3 minus 4/3? What's 2 minus 4? Negative 2. You keep your common denominator of 3, and we keep our W. What you got?
How come whenever you're dividing something, you don't divide with the variable, you just divide with a number, and whenever you're subtracting, you divide or subtract with?
It depends on if you're moving the whole thing. Like if you're moving the variable, you can divide with a variable. And we're going to do something like yesterday when we were doing like it was like 2 times length times width, and we were just solving for width. We had to divide by that 2L to move it also. So if you're moving it, the variable goes with it. But if you're not moving it, you don't take the variable with it. Like if we were solving for this W, we would just subtract 4/3. It depends on whether you're leaving the variable or taking it with you.
Why wouldn't you leave it?
Because we want to combine this W with this W over here, so that's why we moved it. No, we're not done yet. W's not by itself.
If there's one equal sign, side of the equal sign, and if there's one on the other, then you take one of them and move it to the other side.
Yeah. Okay, W is not by itself. They're multiplying by 2/3 W. So we're going to divide because the opposite of multiplication is division. Now, Tristan, this may be what you were just asking about. I am not dividing by W because I want W by itself. So I need to move this negative 2/3. That if I multiply by negative 2/3 W, this whole side would go to 1, and I would lose my W completely. So because I want to keep it there, I'm not dividing by the W. What you got?
So like if they're multiplying the W, even if it's on the other side of the equal sign, still divide it.
Yes. Negative 2/3 divided by negative 2/3 is 1. And so that's how we leave our W there. So we've got to do negative 12 divided by negative 2/3. Do you remember what I told you about dividing fractions?
Oh no, multiply by the reciprocal.
Awesome. You multiply by the reciprocal. What's the reciprocal of negative 2/3?
3.
Negative 3/2. Awesome. And you put that 12 over 1. What's negative 12 times negative 3?
36.
Oh, not negative 36, positive 36. Sorry, my mistake. 1 times 2 is 2. So now we got it. Can we simplify 36 divided by 2? Absolutely. What is it?
12 over 1. So it's completely 12.
So W equals
36 divided by 2 is not 12.
18.
What? Let me show you some mental math. What's 30 divided by 2? 15. What's 6 divided by 2? 3. What's 15 plus 3? 18. So 18 is equal to W. What you got?
Would it be okay if you move 2/3 first?
Yes. And let's talk about what happens. That's a good question because a lot of times when people have the same variable, they're not sure which one to move. You can absolutely move 2/3. It's going to put an extra step in there, but let me show you what happens. If I'm going to move 2/3, that would mean I would need to subtract 2/3 W. I'm taking the W because I want to combine it with this one. 2/3 W minus 2/3 W equals 0. Yesterday in your quiz, people kept saying, well, they cancel each other out. 0 is a number. It's okay to have that. It's fine. 4/3 W minus 2/3 W is 2/3, excuse me, not 2 over W, 2/3 W. I haven't used my minus 12, so I'm going to bring it down. Now to get this W by itself, I need to move this minus 12. What's the inverse of minus 12?
Plus 12.
Plus 12. Oops. Negative 12 plus 12 is 0, and that leaves me with 2/3 W equals
12.
12. Now we have to divide by 2/3. 2/3 divided by 2/3 is W, and we still have 12 divided by 2/3, which we've already worked out to figure out that it was 18. So you get the same answer. You just have to add this extra step of moving the 12 over here now, which is completely fine.
Oh, yeah.
All right, let's skip over to number 7. Draw your line down your equal sign. You need to start looking for variables. What do you notice about this equation?
It's got
It's got H, so we have the same variable. Where is this variable?
Make sure it's
On both
recording.
sides.
On both sides of the equal sign. That means we're going to have to cross that equal sign to combine these together. If you cross the equal sign, you have to use inverse operations. So, I'm going to move this H over here to the right. What's the inverse of minus H?
Plus 8.
Plus H. I'm going to do that on both sides.
You recording?
Negative H plus H is
2.
0.
Yeah.
Think about it as a 1. This is negative 1 plus 1 is 0. Okay? That leaves me with a positive 4 equals negative H plus H is
Cancel
0, and that leaves me with a 9. Well, is 4 equal to 9?
No.
No, so therefore it is no solution. If you get down to a number equals a number, that is okay. If it is not a true statement, 4 is not equal to 9, then it's no solution.
Are you sure you put recording that?
Do we,
I did.
Information?
Thank you
in
for
the
checking.
answer, do we put no solution or void?
You put no solution. Because if this is a multiple choice problem and some of your test tomorrow is multiple choice, the answer choices will be no solution.
Is there gonna be one on the study app that ends up being infinity?
Yes.
Because I got confused about this.
Yes.
Infinity is not
Okay, so let's look. I actually think it's the next problem. The dreaded fraction. Put your line down your equal sign so you know where your stuff is, whether you're crossing it or not. Anytime you see the distributive property, deal with that first. So let's deal with this. What's 1/4 times n?
1/4.
1/4 n. Bring this minus sign down. What is 1/4 times 6?
1 and 1/2.
Ooh, no mixed numbers. Let's go over here and do some scratch work. 1/4 times 6. What's 1 times 6?
6.
What's 4 times 1?
4.
4. Can I simplify that?
Yes.
Yes, let's go ahead and simplify it to 3/2. Now, if all of our fractions had been the denominator of 4, I would have said let's leave this 6/4, but let's go ahead and change it since they won't all be the same anyway. We have no distributive property over here, so I'm just going to bring this down. Now, I have n's. It's always great when I have the same variable. They're on opposite sides of the equal sign, so I'm going to use inverse operations to combine them.
So you divide.
Well, I've got this whole 1/4 n I want to move. And if I want to move that, then I'm going to need to subtract it off of this side. And whatever I do to one side of the equal sign, I'm going to do to the other.
You have to add it.
It's positive, so I have to subtract it.
Yeah.
So I got to subtract it instead of add it. 1/4 n minus 1/4 n is 0. And that leaves me with a negative 3/2. Do not forget that minus sign goes with those numbers. Bring your equal sign down. 1/4 n minus 1/4 n is 0, which leaves me with negative 3/2. And is that a true statement?
Yes.
Yeah, so what does that mean? Infinite number of solutions, not infinity, an infinite number of solutions.
Oh, whenever they're the same number, they're infinite?
Yes, when it is a true statement, 5 equals 5, negative 10 equals negative 10,
I
x
still put
equals
no
x,
solution.
a equals a, anytime. Sierra, what you got? You're going to pop somebody in the head swinging those around. Put them up. Emily.
What if it was like, negative 10 equals positive 10?
Okay, is negative 10 actually equal to positive 10?
No.
No, so that is no solution.
Okay.
They have to actually be equal to each other. It has to be true.
So you weren't solving for anything in this problem?
Well, you were. I mean, you were trying to solve for n. But what this tells me, this infinite number of solutions means I can plug anything in for n, and these will be equal to each other. I can plug 1 in, and these will work out equal to each other. I can plug negative 74.5 in, and they will work out equal to each other. So they're telling you that n equals any number you want to plug in. Abigail.
What if you didn't simplify the 6 1?
Then once you, that's a really good question. You would have ended up with negative 6/4 equals negative 3/2, and you probably would have said this.
Yeah, because you can divide 6/4.
Yeah, so you would need to look at this and say, oh yeah, I can simplify that. So once you got down to the end, you would need to simplify it because if you didn't, you would have ended up with no solution, which is like the totally opposite of infinite number of solutions. That's a good question. Terry.
Well, couldn't we have changed 3 halves?
They do not like, Common Core does not like mixed numbers. There are no more mixed numbers. I don't know why. They've just decided no more mixed numbers. It actually makes everything easier to deal with as an improper fraction.
But mixed numbers are reality.
I
teach you how stuff is real.
I know, and I understand that, and you will use mixed numbers more in real life. Like I know if I'm cooking and it says 1 1/3 cup of flour, like it doesn't give it to you in an improper fraction. But it makes it, yeah, exactly. It just makes it easier to mathematically deal with it if it's an improper fraction. You can always change it to a mixed number, do your math, change it back to the improper fraction. Yeah, I mean, and that's fine as long as you. Yeah, I know, and I understand that, and you can absolutely do it. Just when you get down to the end, change it back to an improper fraction. All right, so let's skip over to number 11. We have a new set of directions that I accidentally covered up. Let's be pink for a little while. Okay, draw your line down your equal sign. Now, what do you notice about this problem? There are 2 different variables. Yesterday during your quiz, I had people turning in answers that look like this. Can you tell me what y is equal to if you don't know what x is?
No.
No, you cannot. You cannot come up with one single answer if you have 2 different variables. Now they're telling us to solve for y. Now I did have at least 2 people yesterday during the quiz say they're telling me to solve for y. I thought I was supposed to be getting y by itself. That's the same thing. Getting y by itself and solving for y mean the same thing. It's kind of like when y'all use slang. They mean the same thing.
Like TXT.
Like what?
TXT.
Yeah, it means the same thing. Like, what's slang? Yes, people do use fresh. And to me, fresh means not stale. Like this bread is very fresh.
It means
But fresh also means what?
messy.
Neat. Yeah, like no. To me, fresh means like your bread is not hard as a rock.
Okay, that was recorded.
Yeah, it's okay. Okay, so if we're solving for y, means I want this y all by itself. So that means I need to move. You with me? Because you do not sound like it.
Pay attention.
I need to move this 2/5 x. I'm moving the whole thing. I'm taking the x with it. God bless you. Taking the x with it. So I'm going to do the inverse of this positive 2/5 x. And so I'm going to subtract 2/5 x. Sorry, that didn't really like a 2. I'm going to subtract 2/5 x off both sides. 2/5 x minus 2/5 x is 0. And I have a y. Can I combine 3 and 2/5 x? Why not?
Because it doesn't have the, you don't know what
They don't
X
have
is.
an X.
Yeah, 3 don't have x. They are not like terms. So I just leave it 3 minus 2/5 x. Is y by itself?
Yeah.
Did we solve for y?
Yeah.
Absolutely, we're done. You can go. That's all there is to it. Abigail.
Alright. What if the 2/5 was a positive? How would you put it?
Like if this was a negative 2/5 x and you were adding 2/5 x on both sides, you would just say 3 plus 2/5 x.
Wait, before you erase this, can I take a picture of it?
Can you take a picture of this? Absolutely. You want me to erase it back to like it is?
No.
Take it this?
Leave it like it is.
Okay. Come on down. Okay, let's skip on over to number 13. What do you notice about number 13? 2 different variables. What else?
Don't miss the mark.
There's a decimal in there.
Whole number is what it equals.
Do you know how, like, let's say a new person walked in the door right now, somebody you had never seen before. Every one of you would stop listening to me and you would be checking them out like there was no tomorrow.
Yes.
Trying to figure them out. Are they going to be mean? Are they going to be nice? You're analyzing the way they walk, what kind of backpack, whether their shirt is tucked in. You are analyzing everything about them. That is what you need to do with these equations. You need to be analyzing these equations. Looking at them, trying to figure them out.
There's no tomorrow.
Like there is no tomorrow.
Tomorrow.
Now, the directions for 11, y'all aren't with me. The directions for 11 are the same thing with this one. So we're solving for y. So I want to get y all by itself. So I know I got to deal with this negative 3 being multiplied.
Five.
And I got to deal with this 1.5x. Deal with the term that does not contain the y first. So let's deal with this 1.5x. This is a positive 1.5, so we have to do the inverse of that, which is
Minus 1.5.
minus 1.5.
Are you still recording?
Egg.
Yes.
Y'all.
If I were not moving this x, then I'd be dividing by 1.5. But because I'm taking the x with me, I got to do the inverse of the whole thing. 1.5x minus 1.5x is 0. And so that's how I've just got a negative 3y equals. Are these like terms?
No.
No. Why not?
Minus 1 point, because it's a variable and
And a-
subtracting that from just a regular number.
Good. We got a constant and a variable term. We can't put those together. 6 minus 1.5x. Sierra, what you got?
Never mind.
Okay.
I got it.
Is y by itself? No. So what is with this negative? Oh, excuse me. What is with this y?
You gotta divide 6 minus 1.5x by 3.
Yes.
Negative 3.
All right. I'm going to divide everything by negative 3. Every little term by negative 3. Negative 3 divided by negative 3 is 1y. I don't have to write the 1. I just write the y. Can I simplify 6 divided by negative 3? Yes, it is negative 2. Bring your minus sign down. Can I simplify 1.5x divided by negative 3? No, let's just leave it. If it won't work out evenly, leave it alone. The reason for this lesson is 2 chapters from now. We're going to be doing this. Do you remember this from 7th grade?
No.
The slope formula.
Oh.
No, please leave.
Right, you are going to love it. It is my favorite thing to teach, and I refuse for you to hate it. You are going to love it as much as I do when we finish.
Isn't that 3 under 1.5x negative?
Yes, it is. Thank you. I did that to see if you were paying attention.
You'll say that every time you miss it.
Yes.
Wait, with that problem, like, could you write 1.5 divided by -3x? Or does it x?
No. The x is over here. This -3 has no x with it.
And that X looks like an upside down line.
Yes, it does. I'll fix it. Y'all are being mean to me today.
No.
Y'all are picking on me.
Mathematical.
I think that's a better way to
Alright,
Yeah, focus on that.
let's look at 15. Y'all stay with me. It says the formula for profit is P equals R minus C. Solve for R. You have to do that first. Because B says use the new formula. If you don't solve for R, you have no new formula. So let's do that. I'm going to bring it down here. I have P equals R minus C. I am solving for R.
So subtract P.
So that means I need to
Add C.
deal with this negative C.
What, I got a question.
What is it, Angel?
But it says P and C already have an equal for, don't you place them, place C and P, place them?
No. Look, A only says solve for R. They have not told us to use these numbers yet. So we're solving for R. We'll use those numbers when we get down to B. Y'all shouldn't even be reading this yet. Okay?
No.
To get R by itself, I need to move negative C. What's the inverse of negative C?
Plus C.
Plus C or a positive C. It's the same thing. Negative C plus C is 0.
So cancel that.
And we have an R. Do you know what P plus C is? It is P plus C. We don't know what that is, and we can't combine them because they're not like terms. So this is A. Now we can look at B. Use the new formula. Well, here's the new formula. P plus C equals R. If you want to switch that around and put it R equals P plus C, you can do that if it makes you feel better. I know some people like to do that.
Yep.
Find R if P equals 350 and C equals 520. So now I'm going to plug these numbers in. What am I going to plug in for P?
350.
350. Plus, what am I going to plug in for C? 520.
870.
Now, how'd you do that?
And I did it, since P plus C, I had to add them up. And I didn't. And I added up in my head.
How did you know you could add these up?
In the 15, 50 plus 20 equals
Yep.
70. So then I 300 plus 500 equals 800. So then I just add 800 plus 70, which equals 870 in my mind.
But how did you know that you could add 350 plus 520?
Because that's the key. And P equals 350.
Yeah, but how did you know that I could say 350 plus 520? How'd you know you could combine those?
And because they're like terms.
Very good. They're like terms, so you can combine them. They're like terms, so you can combine them.
You are so smart.
I bet you did.
You go to college and you take your teacher courses and you get an emphasis in math.
Hey, I gave you 10. No, you didn't. You put it on the board.
Yeah, I'm only doing the odd ones just to make sure that we hit a one of every type because I wanted to make sure that we got to the word problems, and then whenever we finish, I'll go back and ask y'all, are there any even ones you want me to do? Okay. Our new directions say solve the formula for the bold variable. So let's skip on to 17. It's kind of hard to tell what's bold up here, but it is P.
Smart.
So I know I'm getting P by itself. And so I know I have to deal with this negative 2/10 T.
So it's positive.
So we're going to add 2/10 P. T, excuse me. Make your T's curvy so it does not look like a plus sign.
That's what
So
I
we're
did.
going to add 2/10 T to both sides. Negative 2/10 T plus 2/10 P is 0. And that leaves us with
P.
P. Are these like terms? No, so I cannot combine them. So I end up with S plus 2/10 T. Did we solve for P? Is it all by itself?
Yas.
Yes, so that is all you have to do.
Why'd you take the zero?
Just because I didn't write it. I mean, you can write it. It's the same thing.
Is that, wait, what is that?
S plus 2.
That is S plus
It looks like
2.
0.2 T. These were bad variables to write. I don't like S's because all my S's look like 5's. I don't like T's because they look like plus signs.
I just like
I don't like Z's because they look like 2's. I don't like L's because they look like 1's. Like you would just think that they would pick better variables.
So X is the best. What
What
about Y?
I like X's and Y's and M's. Amani, what you got?
And E.
Yes, sign my name and go. Okay, let's look at 19. We're solving for the bold variable, which is what?
T.
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 We only have one term over here. So I need to deal with this N and this R. N and R are being multiplied by T. Anytime you have variables sitting there hanging out and there's nothing in between them, they're being multiplied. What's the inverse of multiplying?
Divide.
Dividing. So we're going to divide by N and R. Do not put this. You are not in the 3rd grade anymore. That is like anti. No more of those.
Why can't we-
Because your big boys and girls are going to see a fraction bar. At no point are you going to see this probably ever again in math class. Ever again.
But then what if we think it's a fraction instead of a division?
A fraction is a division. This fraction, 1/2, is 1 divided by 2.
But why can't we
didn't know
write
that?
the division?
Because you need to get in the practice of writing how you are going to see things. And you are going to see it as a fraction. So you need to get used to that.
I like it.
We're going to divide by NR. We're not going to lunch until I finish this problem. We're dividing by N times R on this side, so we're going to divide by N times R on this side. This may be why we don't know what's going on our quizzes sometimes, because we don't pay attention to what's going on in class. N divided by N is 1. R divided by R is 1. And 1 times T is
T.
T.
Wait, do you have to put the 1?
No, it's just automatically there. We can't do anything with this hot mess over here. So we're going to leave it P times V divided by N times R. This is a fraction. It's also a division problem. All this stuff is the same thing. They just don't tell you that when you're younger because they don't want to confuse you.
Do we have to keep the N low?
People still be
Yes. Because they have it lowercase. Lowercase variables and uppercase variables mean different things.
What do they mean?
Why?
Well, it depends. Like if you're working an equation that has a lowercase v, it's just a regular variable. If you're working an equation that has an uppercase v always stands for volume. So if they gave us numbers, then we would know we would be plugging the volume of something into this.
But the one we did a few days ago had a V and then it was like 1 over 3. So it'd be volume 1 over 3.
So it's 1/3 times the volume. The volume divided by 3. Yes. Terry, what you got?
Okay, and then on the quiz, I think it was on the quiz, there was a lowercase b and an uppercase b.
Yes, there's actually one on this. A lowercase b just means a base. An uppercase B means the area of the base. And we'll get into that more whenever we do our surface area and volume and all that good stuff. Okay, it's lunchtime, so let's pause this.
I wrote it the wrong side.
All right, let's look at number 21. We've got, our directions are saying, they're over here on number 20. It says find the value for x, then find the angle measures of your polygon. So we need to figure out what x is. Well, they're telling us that the sum of the angle measures, what does sum mean? Add. What are we adding?
All this of angles.
All the
The angle measures. So our angle measures, we have x minus 5 plus x plus 35 plus 1.4x plus x equals 360. Now, I don't know if y'all remember me telling you this or not, but see how these have parentheses? And I told you that if you were adding in between the parentheses, you could drop them. So we can drop those parentheses so that we can combine these like terms. What you got, Sierra?
What is the actual 1.4?
That's an x plus x. It's hard to write neat on the slate.
Hey, you'd like take half of it out and just add it up on both.
Do what now?
Take half of it out of you, just add it up on both.
Yeah, well, that's what we're fixing to do. We have x plus x is 2x. 2x plus x is
3x.
and 3x plus 1.4x is 4.4x. Now let's combine our constants. Negative 5 plus 35 is 30, and that's equal to 360. Now we have something that looks a little bit easier to deal with.
Yeah, that's a lot.
Let's look at this equation. Now that we've combined all of our like terms, we need to solve for x, which means we're going to get rid of, we're going to move this 30. Somebody already said the opposite of plus 30 is subtract 30. 30 minus 30 is 0, so we're just going to bring down this 4.4x equals 360 minus 30 is 330. Still trying to solve for x. We need to get rid of just the 4.4. We got to move just the 4.4, and it's being multiplied, so we are going to divide by 4.4 on both sides. 4.4 divided by 4.4 is 1x equals 330 divided by 4.4 is 75. Yeah, if you want to check me, check me. Brett, are you with me, baby?
Yeah.
Okay. Now, that's just part of it. We just solved for x. Now they're asking us to find the angle measures. I realized on this paper it was stressing some people out that there's not enough blanks. I would just write the angle measures over here. It would make more sense. If x equals 75, then this x is 75 degrees. What is 75 plus 35? 70 plus 30 is 100. 5 and 5 is 10, so we have 110 degrees. If you can't do the mental math, come over here and set it up. 75 plus 35, okay? This is 75 minus 5, which is 70 degrees. This is 1.4 times 75. I don't know what that is, so let me come over here and do it. So we can practice multiplying decimals. We need to practice that. 4 times 5 is 20. 4 times 7 is 28. Plus 2 is 30. Placeholder. 1 times 5 is 5. 1 times 7 is 7. Add everything up. I have one decimal place in my problem, so I have one decimal place in my answer, so I end up with being 105 degrees. All right, Abigail, what you got?
There are only 3 places.
I know, that's what I was saying a while ago. The blanks don't mean anything. You can put x equals 75, and then they're just wanting you to put these down. I would write it on the figure. That way you know where those numbers came from. Angel.
I did that. You told me I had the X right there. And I did it on one of my quizzes.
Uh-huh.
And I did that. And then I multiplied it and put it all in that. And it was like, it was wrong.
Yeah, see, and I noticed that on the first quiz that we took, some people did. They got x equals 75 right, but then they came over here and put like 37. Well, you didn't plug the x in right. What you got? Yeah, you just, whenever somebody gets back, y'all just keep going. I also had people on that first quiz, what I did, they got x equals this wrong. Maybe they got 50 right here. But if they plugged it in and worked it correctly, 50 minus 5 is 45. I gave them credit for working these out correctly, but I marked this wrong. Because technically that was wrong. But they worked it out right. All right, so we're going to start doing the word problems now. There are 24 more students in the 7th grade class than in the 8th grade class.
I thought you said I.
I'm not even.
I am. I did the odds on the other ones to hurry up and get to these word problems. Okay? There are 24 more students. More than. What does more than mean? Means add. I'm adding 24 to something. 24 more students in the 7th grade than G, the number of 8th grade students. So that means 24, exactly, plus G. If I take my numbers of 8th graders plus 24, that's going to give me the 7th graders, or how many 7th graders are there, right? Isn't that what that says? Okay. The next part says the 7th grade class has 160 students. Well, what is 160? Is it G or is it the 7th graders? It's the 7th graders. So let's plug that 160 in for our 7th graders. I think it's really important to, whenever you're doing these, go ahead and start writing down what you know. You may or may not need it. It may or may not help you, but it's easier to look at the kind of stuff you're setting up rather than to go back and read this whole paragraph. Write and solve an equation to find the number of students in the 8th grade. Well, look at this. You've already written the equation. You're halfway done, just writing down the things that you knew. So now all we have to do is solve it. We're solving for G, which means we got to get it by itself, which means we got to move this 24, which is minus 24. The inverse of positive 24 is a negative 24, or minus. 24 minus 24 is 0, and so that's where we get this positive G. 160 minus 24 is 136. So G equals 136. What does that mean? Exactly, because G was the number of 8th graders. They were asking us to find how many 8th graders, so that means there are 136 8th graders.
Wait, why they have two
You got two
blanks?
blanks.
Yeah.
I don't know, because it says write and solve an equation. Write the equation, solve the equation. I just got finished telling y'all twice. The blanks don't matter. It doesn't matter. They could have 75 blanks. As long as you answer the question, don't freak out over how many blanks they have.
And would you want us to write the equation on the would you want us to write the equation the answer to, or you don't need it?
Yeah, if it says write and solve the equation, I do want you to write the equation. Now, if this were a multiple choice problem, it would probably just ask for the number of 8th graders. It probably wouldn't be part of it asking for the equation. Yeah, there are some multiple choice on there. There are some matching where it gives you several equations and several answer choices and you just match them up, which is basically like a multiple choice. And there's some that are short answer, like the ones that we're working now. All right, let's look at 23. You rent a canoe for $5 per hour. What have I been telling y'all per means?
Time.
Times. So this is 5 times how many hours? Okay? So that means if I rent it for 1 hour, how much have I paid? $5. If I rent it for 2 hours, how much have I paid? $10. If I rent it for 5 hours, how much have I paid? $25. The cost before tax is added is $12.50. What does is mean? Equals. So we know our total cost equals $12.50. Does 5 times our hours give us our total cost?
No.
How much money am I spending if I rent this for 1 hour? $5. So how much will my total cost be? $5. If I rent this canoe for 2 hours, how much am I going to have to pay again? $10. So what's my total cost? $10. If I rent this, stay with me, for 3 hours, how much am I paying?
15.
15. So what's my total cost?
15.
15. So does it 5 times however many hours I rent it for give me my total cost?
Yes.
Yes, it does. So I can replace this total cost with 5H is $12.50. Everybody okay so far? We need to solve for H because we want to write and solve an equation. We just wrote the equation. Now we want to solve it to find the number of hours. So we're going to do what? Divide by H because it is being, divide by 5 because it's being multiplied by H. That cancels. And we're left with H equals 12.50 divided by 5. So let's go over here and practice some long division. Everybody's favorite thing to do.
No.
Can 5 go into 1?
No.
No, so you better not have a number over that 1. Can 5 go into 12?
Yes.
Yes. 2 times. That 2 goes over the 12. 2 times 5 is 10. 12 minus 10 is 2. Do not bring this decimal down. The decimal only goes up. Bring the 5 down. Do not bring down, do not make this 2.5. It's just 25. How many times is 5 going to 25?
5.
5, and 5 times 5 is
25.
25, which is 0. Bring the 0 down. How many times is 5 going to 0? 0. So how many hours did we rent this canoe?
$2.50.
2.5 minutes.
Ow.
Hours. 2.5 hours. 2 hours and 30 minutes. However you want to say it.
If that wasn't a test and we just put H equals 2.5, we would get it wrong.
No, because H does equal 2.5.
I know, but I was just saying if we didn't put like 2.5 hours.
No, that's okay. Well, I mean, this is 2.5 hours. If you didn't put, I wouldn't be expecting, you could put 2.5 hours or you could put 2 hours and 30 minutes. I would take either one of those because they're the same thing. Okay. For the second time, we did all the odd numbers just to get up to the word problem so that I could work all the word problems for you. I said it before class started.
Why are we doing 24? Let's do that for you.
Oh my goodness, I just said that. All right, everybody listening to me? I've worked all of those odd problems. Hayden, you better put that ruler up. I don't ever want to see it again. Put it up. We ain't measuring anything. I worked the odd problems so that I can have time to get to the word problems. So that I can work all of them for you. Then, when we're done, we are going to go back and I will work the even ones that you asked me about. But the whole purpose of working only the odd was to get to these word problems. Now, I do not want another person asking me, why are we working the even ones? Because that's like the 4th time I've said it. Or the 3rd, I can't remember.
Still recording.
It was a third.
Yes, it's still recording. So all y'all's parents are going to know that I have to repeat myself. Because y'all don't listen. Yes.
Love you.
I listen.
All right, the cost in dollars. You're not listening right now. You're not listening right now. You're not listening right now. The cost in dollars of making N birthday cakes is represented by C equals 24N plus 35. Thankfully, they gave us the equation this time. We don't have to try to figure it out. How many birthday cakes are made when the cost is $3.95? So I need to plug this $3.95 in. Where am I going to put it?
For E. I think.
For C or for N? That's my only two options. Well, C is, they didn't tell us what C is, but they told us that N is the number of birthday cakes. Did we make $395 birthday cakes? No, that doesn't even make sense.
But you can tell because it's the cost.
Exactly. The cost starts with a C, so
It's $3.95.
common sense tells you it's going to go here. So you have $3.95 equals 24N plus 35. Draw your line down your equal sign. We're looking for variables. We only have one. It's only on one side of the equal sign, so we're solving for this for this N. We got to get rid of the 24. We got to get rid of a positive 35. We're going to move them to the other side.
Subtract 35 on both sides.
Exactly. We're going to move this 35 first by subtracting 35. 35 minus 35 is 0, and so that leaves us with 24n. 3095 minus 35, 5 minus 5 is 0. 9 minus 3 is 6.
360.
And 6 minus 0 is 3. Some of you are acting like you do not have a test tomorrow. I am not working these problems for me. I'm working them for you. You should be paying attention whether you're going to go home and watch this video or not. You need to be paying attention now. We are trying to get n alone. We're isolating it, so we got to get rid of this times 24 by dividing by 24. That goes to 1 and leaves us with n. Can we simplify this?
Yes.
Yes. Now, I don't know that 24 is going to go into 360 evenly. I have doubts about it. So let's simplify this because we may need to just leave it an improper fraction. These are both even. What's going to go into both of these?
2.
2. Half of 24, it's easy. It's 12. I'm going to do it first. Let's do half of 360. What's half of 300?
I was going to say.
150. What's half of 60?
30.
30. So we have 180.
I'm sorry, Mom. I'm sorry.
That's okay. At least you admitted it. So we have 180 over 12. Can we simplify this even more?
Yes.
Yes. By what?
2.
2.
We should have did half.
What's half of 12? 6. What's half of 180? Half of 100 is 50. Exactly. 90. Can we keep going?
Yes.
Will 90 go into, will 6 go into 90 evenly?
Yes. Yes, it will.
Let's go over here and check. I would much rather do 6 into 90 than 24 into 360. 6 goes into 9 one time. 1 times 6 is 6. Yes, it will. How many times will 6 go into 30?
5. Yeah.
5.
So 15.
So 15 equals n. I am amazed at the number of people that are still not paying attention.
Wait.
Absolutely. What you got?
On our 24, it says C left.
Yeah.
What did I tell y'all about those blanks?
Don't worry.
No, I was
Don't worry about it. It's okay. No, the blanks.
I'm average.
Don't worry about it. It says see left because this says explain your reasoning, and you cannot explain your reasoning on that teeny tiny little blank.
Unless you're right.
They want you to go over there and do it to the left. Now, explaining your reasoning to me, you just explained your reasoning when you worked this problem out. What is 15? I know it's n, but what is it?
The amount of cake.
The number of birthday cakes that you can get for $395. Is your hand up?
For the study guide, do we have to work all of them or can we just work the ones we need help on?
The ones you need to work on, because I'm not taking this back up.
Okay, so like we didn't do all of them in which
I didn't have to do
All right, question. Any other questions on this one? All right, so let's look at 25. I really like this question. There's a lot of thinking involved in this question. They're asking you about perimeter, so you have to know that perimeter means addition of all the sides. Well, they only gave me 2 sides. But if you keep reading, they're telling you that it's a square. So what do you know about a square?
They are equal.
They're all equal.
Well, that's not.
Are they?
No. Yes.
Is this equal to this?
Yes.
Yeah, we can make it. All we have to do is this. 4x plus 3 equals 3 times 2x minus 5. If this is a square, then you bet, yes, they are equal to each other. So you just set them equal to each other. What do you see first? Distributive property. Awesome. 3 times 2x is 6x. Bring this minus sign down. 3 times 5 is 15. Make sure you distribute to both of those numbers, okay? Let's bring down this 4x plus 3. We have the same variable. Thank goodness. It's an x. It's on both sides of the equal sign, so we got to cross them over to combine like terms, which means we're going to use inverse operations. I'm going to move 4x. It's always easier, remember, to move the smaller one. So let's move 4x. It's positive, so we're going to subtract 4x off both sides. 4x minus 4x is 0, and so now we just have that 3 over there. 6x minus 4x is 2x, and I hadn't done anything with this minus 15, so I'm just going to bring that down. Now my x's are combined. Let's combine our constants. Let's isolate this x and move this negative 15 over here. The inverse of that is positive 15. Negative 15 plus 15 is 0, and so that leaves me with a 2x. Do not forget to bring your equal sign down. 15 plus 3 is 18. Divided by 2 because they're multiplying by 2. 2 divided by 2 is 1. What's 18 divided by 2? 9. Now, are we done?
Yes.
Yeah.
We got the X alone.
Did we find the perimeter? Now, we're done with this problem. Yes, we've worked this problem as much as we possibly can, but we haven't answered their question yet. They asked us to find the perimeter. What am I going to do with this x equals 9?
And then times and 3 and
We're going to plug it in. This is equal to this. So you only have to plug it in one of them. Which one do you think it would be easier to plug it into?
4x plus 3.
4x plus 3. Because if I plug it in down here, I got to distribute and I got to do, I just don't want to do all that. So I'm going to plug a 9 in here. So I have 4 times 9 plus 3. What's 4 times 9? 36. What's 36 plus 3? That means all 4 of these sides are 39 inches. So I still haven't found the perimeter. I'm doing all this work. I still haven't answered the question yet.
Well, how did you find the
Because perimeter means add all the sides. So now that I know that all the sides are 39, I can say 39 plus 39 plus 39 plus 39 or
39 times
39 times 4. What's 4 times 9? 36. What's 4 times 3?
12.
And 12 plus 3 is 15. So I know that my perimeter is 156 what? Inches.
So which one would be the correct?
The correct answer, they ask you to find the perimeter is 156 inches.
Wow, that's a lot.
Thank you, ma'am.
You're welcome. Okay, on number 26, it says that George makes a payment of $1,000 down payment for a car, and then he pays $325 per month. So what do we know about George?
He makes $1,000 payment.
He makes a $1,000 payment,
He's rich.
and then he pays what?
$325 per month.
What does per month mean?
Every month.
Every month. And what does per mean? Multiply. So we're multiplying by the number of months, and we don't know the number of months, so we're just going to put an M. Okay? Elaine makes a $2,500 down payment for a car and then pays $325 per month. So what do we know about Elaine?
She makes a $2,500 payment and pays $325 a month.
And she pays $325 per month. Okay? And so it says, is there any number of months in which both George and Elaine will have paid the same amount? What do we talk about when it says the same amount? Equals. We're going to set them equal to each other. So let me get a different color so we can see it. So I have George, and I want to know, and this slate is just messing my handwriting up. I want to know if at any point George is going to be equal to Elaine. Okay, you're going to draw your line down your equal sign, and we need to start looking for variables. I have one variable of m. So this is not a literal equation because it only has that one variable in it. But we have that same variable on both sides of the equal sign. So we're going to have to use inverse operations to move it from one side to the other. I'm going to move this 325 over to the right. And so I have to do the inverse of plus 325, which is
Minus 325.
minus 325. And I want to move the m too, so I'm putting the m with it. So I'm going to minus 325 m over here.
That's
325M minus 325M is 0. And so that leaves me with 1,000 over here. Bring your equal sign down. 325M minus 325M is
Zero.
0. And that leaves me with 2,500. What happens when you have a number equals a number and it's not equal to it? No solution.
No solution.
That means there is no number of months in which George and Elaine will have ended up paying the same amount. If they're paying the same per month, Elaine is always going to have paid $1,500 more than George. Now, if George's monthly payments were more than Elaine, then eventually he would catch up to her. But because their monthly payments are the same, Elaine's always going to have paid more. Does anybody have any questions about this one?
No, ma'am.
Yeah, don't be upset when you come down here and you're like, oh my goodness, I have a number equals a number. During your quiz yesterday, you're like, well, this cancels out on both sides. It's okay for that to happen. It is okay. All right, let's look at number 27. Number 27 looks kind of scary. This is what you've already worked, the triangle one that's just like this one. It's just like the I equals PRT. It's just got a trapezoid, okay? It says the area of a trapezoidal car window is given by this formula. That is your area of a trapezoid formula. Now, they usually have base 1 plus base 2. They've changed this to a lowercase b and an uppercase b just to keep them a little bit more separated. And A says solve the formula for the uppercase B. So we want to get this uppercase B by itself. Yep. And so we're going to draw our line down our equal sign. Do you remember what I told you about when you have a fraction that should be distributed, how to get rid of that?
Multiply the reciprocal.
Good. You're going to multiply by the reciprocal. What's the reciprocal of 1/2? 2. 2 over 1, which is just 2. So either way you want to write it is fine. This 1/2 and this reciprocal go down to 1. So it's basically like they're gone because it's multiplying by 1. Over here, do I know what 2 times A is?
No. 2A.
It's just 2A. Can't work anything out. And I'm left with H times B plus B. Everybody's okay with what just happened?
Yes.
Now remember, I'm trying to get this B by itself. So I need to get rid of this B and I need to get rid of this H. Let's get rid of the H first. This H is being multiplied. What's the inverse of multiplying by H?
Divide.
Divide. God bless you. So let's divide
All that by H.
both of these sides by H. H divided by H is 1. And so that's 1 times B plus B, which is just B plus B. I don't know what to do with all of this. There's no numbers to plug in. I can't combine them because they're not like terms, so I just bring it down. Now, I'm still trying to get this B by itself. It's positive. So I just need to move this positive B. And how am I going to do that? Subtract B off both sides. B minus B is 0. And so that leaves me with the big B that I was trying to get by itself in the first place. I can't combine any of this stuff over here, so I have to leave it as 2A divided by H minus 6. Oh, wait, that's a B. That is right. That's a B. Sorry, I couldn't read my own handwriting. Now, is the big B by itself?
Yes.
Yeah, and that's what we were trying to do. Austin, this is what we've been working on since you were out. And I know that it looks crazy because there's no numbers, but I'm going to make it make sense to you, I promise. This was a bad problem to start you out on. They're not all this difficult.
Did you stop the recording?
No. Okay, now that's A. We solved the formula for the big B. Now, the second part of this says use the new formula, and our new formula is 2 times A divided by H minus B equals B. When the small b is 22 inches, H is 20 inches, and the area is 500 square inches. So we're just going to fill that in. So we have 2 times our area, which they said was 500, divided by H, which they said was 20. minus the small b, which they told us was 22. And that's going to equal big B. You got to follow the order of operations. Please excuse my dear Aunt Sally. 2 times 500 is 1,000. 1,000 divided by 20 is 50. I'll save you some long division. 50 minus 22 is 38.
Equal B.
Equals B. And so that's our answer for our second part of our problem. And that's it. Any questions on this problem? Everybody's okay? Yeah.